Okay, hi everyone. So, as promised, this is probably a reasonably long video, but I'll split it into chapters, looking at how we can integrate some AI workflows into what we're doing in Blender. I really think this is going to be a really important direction that we're going to go into as artists over the next few years. The interfaces may change, but that's no reason to sort of ignore them. And what I've tried to do here is I've worked with one of our fantastic computer science PhD students called Manho, who has developed what I'll upload as a Google Doc, is this really excellent sort of explainer guide. And in this video, I'm going to walk through it and show how we can go from the Vanitas project we've been making so far as a sort of conventional 3D animation in Blender to something we can play around in this, which is called ComfyUI. This might look really complicated, or it might look really familiar. Like these sort of nodes with these connections is very similar to what we've been using in the geometry nodes and in the shader editor in Blender, but we have some kind of what I find quite new, slightly difficult computer science stuff in terms of loading machine learning models. But I hope by the end of this video you will understand how to get started and then maybe have the motivation to take this further and to experiment with it yourself. A quick note, a lot of what I've got in this video is based off this fantastic tutorial by Mick Mumpets, who does, I would say, a much more detailed job of showing how to move between Blender and ComfyUI. So I'm going to take a couple of techniques from this, but I'm going to try to keep it one, a bit simple, two, with a bit more background information, and three, I'll optimize the workflow for, I guess, like less than amazing machines. You know, we might not all have powerful graphics cards. So everything here is built for, I guess, a more like conventional machine. Okay, the other thing I'm going to point to later in the video is a few like video tutorials like this one that can show you how to install ComfyUI on a Mac. So hopefully we can get through some of the installation processes there. Okay, so let's first of all start in Blender. What we're going to do is we're going to go, if I go back to, well, actually I think it's in my ComfyUI folder. If I go to my ComfyUI folder, I've been making some input images. And this is based on the tutorial I just showed. They're what's called conditional input images. So here we have what's called a depth pass, and you recognize the scene, but what the depth pass is telling us is that anything that's closer to white is closer to the camera, anything that's closer to black is further away from the camera. So it's a very specific type of image encoding. Here I've just got like a regular render, which is you know, from just using a diffuse composite, what we've been doing already. And here I've got like a line pass. So what we can do is, I'll show you just one more thing I've prepared, because if you want to make an animation, you'll need to prepare this as well. So I'll just jump over to my teaching folder and go into my frames. And I just want to show you what I've done in my depth pass is I've actually made like the animation. So if I just scroll down a little bit to where the ball is moving, you'll see that I've rendered out the actual animated frames. And what's really cool about this is that this can be a fantastic image prompt for an AI, because we're giving it a really specific set of conditional information. We're going to use something called a ControlNet, which means that we can prompt the AI to keep all of our composition, all of our depth, and even our animation, but we can totally reskin this into something like what I had on my screen before. Something like this. And what's super interesting here is that this AI setup doesn't have any of our texture or lighting information. It's just got the depth pass, and we can start to make like totally new looking animations. Here, if I go to my image prompt, I prompted it with something that's, where's my prompt? Something here that's pretty similar to our theme: Dutch Vanitas painting, flowers, vase, book, dominoes, vase, skull. But of course, we could prompt it with something totally different and start really like playing around with our results. Okay, so first of all, let's just set up Blender to make these two render passes, the depth render and the line, that sort of outline render. Okay, so we've talked a little bit in class about the compositor view. If you pop over into the compositing tab, if you don't see two nodes here, just tick this use nodes button and they should pop up. I might have a few extra options here just based on the version of Blender I'm using and the fact that I've already been playing around a little bit. I don't really need the console editor here. I might just close that. Okay, so I'm going to press Shift A and I'm just going to add one more node called a viewer, sorry, not preview, a viewer node. Pop that here and I'm just going to connect that to my image as well. So far we see nothing, but that's fine. I'm just going to render an image, and that should just give us basically the same image that we've been looking at every time, which is our regular like diffuse or color composited render with all our lighting and textures and so on. Okay, so there we go. Now if I pop back into Blender, we can see that in our viewer we can see that. And just as a quick demonstration, so you know what the compositor is doing, if I go something like, I don't know, HSV adjust and pop that in there, this is, you know, the compositor allows us to like post-process our render. Think of it like stuff you might do in After Effects or something like that. A lot of the time you don't need to do this. You know, Blender's really good at calculating lighting and shadows and all sorts of stuff. But depending on your workflow, you know, working in the compositor might be something you do. All right, so I'll just connect that back up. But this is where we're going to set up our other render passes for depth and the outlines. And it's pretty easy to set up. So if I go into my view layers and I just click Z, you'll see that depth passes up here. Appears. All right, so first of all, I'm just going to render that again, just to check that in the background, we're actually producing this depth render. This should just take a second. And once it's finished rendering, we should be able to view our depth render. And then we're just going to do like a couple of changes to it. So I'll just go back into Blender here, and I'm going to connect the depth to the viewer and have a look. Okay, so we've got the depth render, but it's kind of all backwards. It's got the white at the back and the darker things at the front. So I'm just going to press Shift A and put an invert color here, which just flips it upside down. But you can see that the levels are all wrong. We can't see the books and stuff. So if I search and put in a levels, I guess, or maybe curves would probably do it too. RGB curves, pop that in there. And I just want to move these around until we get something that's a bit more like, I guess, gentle. You can just click anywhere and add in a new thing, and you can play around with these levels. I don't know. No, that's too much. Something like that might be... Something like that will probably work fine. What we can also do is we can also put in an output, file output node, pop that there, and then just grab a file path and make a folder. I've done this a couple of times before, so I could just make a new one and call it depth pass 2, hit enter, and just select that, hit accept. And that should just, if I connect this here, that should mean when I do my render, I'll get my depth pass. If you want to get the whole animation instead of just that frame, you just go render and render the animation, and you'll get the whole animation. Okay, so that's our depth pass. The next one is that line pass. It just had outlines for everything. So in that case, we just need to turn on a plugin. If we go to Preferences, and I type in the filter free, then we get this thing, Freestyle SVG Exporter. And we're going to use this later when we do some of our laser cutting. So just make sure that's ticked. Once you've ticked it, just check that Autosave Preferences is on. If it's not, turn it on, and then you can also just hit Save Preferences, and that'll make sure that Blender has turned on that plugin. Okay, then we need to activate it. So if I go into my Render tab, now I've got this option Freestyle SVG Export and Freestyle. And once I've ticked both of those, we get this another render layer here, which says Freestyle. I need then to look into my view layer. There we go. And here's all the settings for freestyle. The main one we need to change is the line color. Your base color by default might be set to black like this. Just click on the color and drag that up to white because we want a black background with white lines on it. These things here, the edge types, they can be kind of interesting and useful to play around with, depending on, like, if you wanted to render all of the mesh, like with all the lines here, you'd add edge marks, and then we can talk about that in class. But in this case, border, crease, and silhouette should be enough. It's just sort of guessing where we want the lines based on the border of the objects, creases in the objects, and the silhouette of the objects. Off the top of my head, I'm not really sure the difference between a border and a silhouette, but I'm sure we could work that out with a quick Google. Okay, so same again. I'm just going to render an image, and this might take a little bit longer because it'll do our regular color render with the depth pass, but in this case, it's also going to add a freestyle calculation. And after I've finished stalling with talking, okay, there we go. It's rendered the image, and we'll see up here, you'll know when it's working when it says something like calculating freestyle or calculating map or something like that. We can see the render still going. There it says freestyle mesh loading, freestyle blah, 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 calculations done, stroke rendering, all done. We can't see anything, but if we go here now and I connect my viewer to my freestyle, there we go. There's our line pass. And again, you could just put another file output node. I'll just duplicate this, connect that there, and then just make a new folder and call it line set pass number 2, because I've done this a few times. Set it there, hit accept, and then you could render that. If you want to render the whole animation for both of these, that might take a while just because the freestyle slows things down a little bit, but you can always do that, but just letting you know. So if you're going to do the depth and not the freestyle, I would be inclined to turn this off. And then if I turn this off, it'll probably, yeah, it'll break that connection. But anyway, so that's the line pass and the depth pass, and that's all we need to get started with ComfyUI. Okay, so the next thing we're going to do is we're going to install ComfyUI. And in my experience, this was one of the most difficult parts of the whole process. So hopefully with this guide that Manho has created with a little bit of instructions from this video, hopefully you can all get it done. So if you're on a Mac, the easiest place to start, this is what I did, is I went through this video, which I'll put in the description, and that managed to get ComfyUI installed on my machine. What we have here is, I guess if you're on a PC, you can just go straight to the official GitHub web page and install ComfyUI using the instructions they have here. So just read them very carefully and install them following the Windows instructions. If you're using a Windows system that has an NVIDIA graphics card, lucky you, you should be able to just go straight to the official GitHub of ComfyUI and follow their instructions here. Should all be, just read down and there should be some instructions there. Okay, so once you have installed it, so I'm going to be on a Mac, so I'm just going to quit my terminal session here, and I'll start a new one. So here's my terminal session, and so I've already done that whole installation process, and all I need to do is point my terminal to this directory. So I just go cd space and just drag the directory name here and hit enter. That should change the directory, and then I just need to run this Python script here, main.py. So this is also in the YouTube video. I'm just going to type python3 main.py, hit enter. It's going to do a whole bunch of stuff, and then eventually it's going to give me an address here, which I'll just copy and I'll close this old one because I've actually logged out, and I'm just going to paste that into my browser. So here's ComfyUI as of the last time I was using it, and it's got the previous workflow I had. The next thing we're going to do is I want to bring you over to this document from Manho. So the first few steps, either if you're on a Mac, you can check out that YouTube video. If you're on a Windows computer, you can try one of these two options. The next thing you'll need to do is install the ComfyUI Manager. And that is a plugin that looks for ComfyUI add-ons, because there's lots of different nodes that people use in different workflows that might not be downloaded with your original vanilla installation of ComfyUI. But that's what the manager does here. And so I've got the manager installed, and the installation guide for the manager is here in this link. So just follow this link and follow the instructions. Okay, so that is the installation process. The next thing I'd like to discuss is what ComfyUI is and what its components are. So I'm just going to grab a screenshot of this image here, which is from Manho's documentation, and I want to go through these components one by one. Now, forgive me, any computer science students watching. I'm not a computer scientist, so I'm really just reading from what Manho has explained to me, and the document here. But I think it's useful because it gives us kind of an understanding of what all these things are, so that when we're using them, it's not a complete mystery. We know what these different components are and why they're there. Okay, so the first thing is like the backbone model or base model that we're using, which in this case is Stable Diffusion, which you might have heard of. So that's a basic text to image model. Excuse me. There'll be different architectures we can use in Stable Diffusion, from Stable Diffusion 1.4, 1.5, 2.1, XL, Stable Diffusion 3, Flux, etc. We can assume that as we're moving from left to right, things are getting a bit more powerful. Manho has sort of pointed out that Stable Diffusion 1.5 and Stable Diffusion XL is where most of the community development and resources are, so that's where we're going to focus. And Flux probably relies on a level of processing that most of us don't have access to on our home or lab computers. And actually, for all of the demonstrations I'm going to do in this tutorial, I'm sticking to 1.5. I've got a decent laptop, but it's not, it's not designed for this type of work. So when you'll see me repeatedly throughout the videos setting the backbone model, and I always set it to a Stable Diffusion 1.5 checkpoint file that I've downloaded, and I'll show you where to download those in a moment. Okay, and then we have all these different models that adapt kind of how Stable Diffusion is functioning. And here we've got a quick description of them. So a Lora, a low rank adapter. Because deep learning models are data-driven, they can't understand concepts that they haven't been trained on. But what we can do is we can make a low rank adapter as an efficient way to adapt the model to understand new concepts, trained by a much smaller data set. And we can use words that can trigger what that features from that small data set contain. One of the drawbacks or the weaknesses of this approach is that Loras tend to be very, very specific. So the Lora might have been optimized for a certain type of image, a certain type of prompt, and once you go outside that, it might not work as well as some of the images in the page, the download page or something like that, some of the sample images. Okay, an IPAdapter. An IPAdapter is kind of interesting. That's where we can use images as a prompt. With an IPAdapter, we're kind of extracting like very abstract features of the image. We don't have a great deal of control over what features of the image get extracted, which can be artistically quite fun. It can be a much more sort of fluid process. If we compare that to a ControlNet, that's what we're going to use our Blender outputs for. A ControlNet is used to control the image layout structure of the generative image using a conditional image. So that's what those depth and line passes were. They're conditional images that have a very set encoding of, in the case of the depth depth map. What does a light and a dark pixel mean? Or in the case of an outline image, you know, outlines represent the borders of different objects. And if the ControlNet is trained on that, then we can have a lot more control over how that image interacts with the text prompt to create something new. So that's what I was doing in this example here. And I'll try to, you know, name all the chapters in this video. So if you want to skip straight to here, you can. However, I still recommend you're going to have to watch all the installation steps to make sure you download all of the different models that we still need to run this workflow. Okay, so let's just continue looking through here. I'll get my image back. AnimateDiff. AnimateDiff upgrades Stable Diffusion from image generation to video hallucination. Vanilla AnimateDiff only generates 16 frames together consistently, you know, without jumping into weird stuff. But additionally, the ComfyUI plugin has already set up infinite long sequence generation if you have enough GPU memory. So this is cool. This is where we're going to start making videos and animations instead of just still images. And LCM. LCM, or latent consistency model, is a special pipeline that can speed up inference speed by decreasing the denoising step. Denoising we've actually talked about a little bit in class when we look at rendering. That's where basically, you know, the computer is starting off with, you know, a latent space or just a complete image of random noise. In this case, in Blender, it's how we calculate lighting, and either we denoise through throwing more samples at our render, or clever algorithms that can make the image look cleaner without having to throw so many light samples at it. And I think we're talking about something similar here in principle, even though the process is quite different in terms of how these LCMs do their denoising. But the main thing we can think about, if we understand what denoising is that this should speed things up. However, it requires fine-tuning of a special LCM model. However, there are some special LCM Loras to implement LCM in a Lora fashion. And Manho has very generously set up a few different workflows that show this, and I go through them later on in the video. Okay, so the next thing we need to do is download all of these checkpoints and AI models that we need to run these workflows. Manho has very, very kindly put the link to all of the model examples that he uses in his workflows. Manho has said you can follow the workflow tutorials instead of directly downloading the models first. That's up to you. I'm going to just suggest that you download a series of these models, and then I'll just run you through the workflows one at a time. But if you only want to do one thing, then as Manho suggests, you know, you don't have to download all the ones that you might not use. But they're listed kind of in the order that we use them. Okay, so if you look at these prefixes here, SD 1.5 and SDXL, that is looking at, I closed that image, but that's looking at like what our backbone model is doing here. Stable Diffusion 1.5 or Stable Diffusion XL. As I said before, I use 1.5 because my computer is pretty good, but not fantastic. And I assume you're probably going to be using that too. So that's what we would be loading here as a checkpoint in the beginning of pretty much all of the workflows we use, with the exception of the LCMs. Okay, so what we've got here, in each case, I just want to show you the folder structure. When you've got ComfyUI installed, I'll drag this down, you'll have all of these folders already set up. And basically what this guide is telling you is that for each of these checkpoints or models, you need to put them in the folders that are designated here. So ComfyUI models checkpoints. If I go ComfyUI models and checkpoints, here I've got my Stable Diffusion 1.5 and Stable Diffusion XL. But I've just been running the 1.5. I recommend setting up two folders like this, and that's where you'd put your checkpoints. So if I go to this link here, just as an example, I'll open the link, and then this is taking us to Civet AI, and this is where a lot of different models are shared, a lot of different workflows are shared. User beware, you know, people use these models to generate any image you can imagine. So I can't take any responsibility for the type of images you'll find. if you're not signed in, I think they're filtered somewhat, so we shouldn't see anything too unsavory. But just beware. You know, we're on the internet, and any image you can imagine is probably there. So my apologies in advance. Okay, but we've gone to the Civet AI page, and here we just download the model. This, you can see the model's pretty big. It's almost 2 gigabytes. And I think this is probably one of the larger models that you'd need to download. The SDXL will be even bigger. Let's have a look. I think probably substantially bigger. Yeah, so that's 6.6 gigabytes. But the quality should be better, but your machine might not be able to run it. All the demonstrations I'm doing here are with 1.5. But if you follow my examples, it's exactly the same as using Excel. You'd just be setting your ComfyUI to the Excel checkpoint file instead of the SD 1.5. Okay, so I won't go through all of these, but because it's pretty much the same thing. If you look at your folder directory where you installed ComfyUI, look where Manho is telling you to install the model, download the model, and from your downloads folder, just copy it into the correct folder. Again, in some cases, there might be models that are specifically for Stable Diffusion 1.5 or Stable Diffusion XL. So you might need to just check those as you're downloading. And in some cases, Manho might have given us instructions if we need to rename something. So I think we've got this here, rename, and that will correlate, I think, later in the instructions. Okay, so you can see the models here. Now we're in ControlNet. That's where we're using our conditional images. He is giving us an example here of Stable Diffusion 1.5 and the file that he's using. And so you should just be able to go down here, download, and put them in the right folder, all the way down to the LCM. Okay. And then the next chapter we'll be looking at the workflow examples. And that's where we will learn how to implement these into something like this. And where we're going to start is with the workflow examples. So this is where ComfyUI gets like really cool. There's all sorts of different workflows you can download. If we open this link here, people will upload all sorts of different workflows. Again, I'm super new to this, so I will probably get lost here pretty quickly, but I want to follow the guide that we've got here and just see if we can get things working. Okay, so let's start at the beginning with text to image. So what we're going to do is I've actually uploaded the workflows that Manho has prepared for us in a Google Drive that I will make available to you in the description. So we're going to start with the first one, which is text to image Stable Diffusion 1.5. So if I find that JSON file here, text to image Stable Diffusion 1.5, and I drag it into my ComfyUI, then we can see it's a much simpler network. And what we've basically got is we're loading the checkpoint file, which in this case, I might just have to reset it to my Stable Diffusion 1.5 here, just because that might be referencing the one that Manho had on his computer, might be referencing his directory. What else do we need to do? If we see here, we've got two text prompts. One is a positive prompt and one is a negative prompt. And we can see that if we sort of stretch these out a little bit, it's kind of telling us what they are. This is the positive prompt saying everything the image should have, and the negative is everything it shouldn't have. Now, I'm just going to leave the prompt in there. Moody aesthetic, beautiful, cozy, cramped bedroom with floor-to-ceiling glass, blah, blah, blah. And then it's saying no bad eyes, no CGI, no airbrushed, no plastic, no deformed, no watermark. The latent space is going to be the resolution that we're going to output with a batch of 1. And then we're going to get an image preview. And the save image has been muted. If we just press Control B, or bypassed, I think is what they use in ComfyUI, we can turn these on and off. On the Mac, it's Command B. On a PC, it'll be Control B. So I'm just going to press Q prompt, and that's going to run the model. And then if I just pop over to my terminal, if I'm on a Mac, you can see that this little thing here where it says 0%, that tells me it's still running, which is the same here for this little taskbar on the K-sampler node. And it's telling me that it's going to do 20 steps, and it's at step 2 of 20, and each step takes the same amount of time, so then it can tell me roughly how long it's going to take. And it's telling me it's going to take about, I don't know, 2 minutes and 9 seconds or something like that. So I'll just wait for that to finish, and when it does, we should have our preview image here. Okay, so the generation is finished, and if we look close up, the image looks a lot like the sample image that Manho has put here. So let's just have a quick read of his description. He says that the prompt, it's an input to guide the AI to generate what we want. The prompt can be text or an image prompt, which would use an IPAdapter. Every model is trained or fine-tuned to its own data set, which means that every model will have its own strengths and weaknesses in what it can generate. So if we look at these two different prompts, and then here we've got two different base models. This is the base model we're using here, which if we go back up here, is the Stable Diffusion 1.5. We've got this, and then with the same prompt with the Stable Diffusion XL Juggernaut, you can see there's like quite a big improvement in quality. I'll just zoom in a little bit more. And then with the second prompt up here, a path in the woods with leaves and the sun shining and so on, we've also got a similar kind of difference in quality. But again, I think this is really just a starting point for you to experiment for yourselves. Okay, so let's move on to the second workflow using a Lora. So a Lora is a text-to-image workflow, and let's just grab this Lora A model that Manho has made for us. So I'll pop over into the into my Comfy Workflows folder, and I'm going to grab this Lora A JSON file and just drag it in to my ComfyUI browser window, and let's take a look. So let's just take a look at what Manho says here. So a Lora, we've got two files here. One with Lora A is the text-to-image workflow without any Lora, and Lora B is a text-to-image workflow with a Chinese ink style Lora. So let's just quickly see what he means by that. He's put this together in a really nice way. So if I just go to my workflows and I put in Lora B, you can see that all that's actually going on is we've just muted these two. So if I shift select both of these and Command B, we're just turning them on and off, which is with or without the Lora. But just to keep things simple, I'll go into Lora A, and let's look at the description. So this prompt here, I mean, you'll see that a lot of the AI models, you know, for the biases of whoever's generating them, often have generating images of women, which seems to be a bit of a trend in the AI field. But I want you really to focus on the aesthetic content here. So without the Lora, we've got this like, you know, sort of very smooth looking CGI image. And with the Lora, we've got this style that seems to be, you know, somewhere between like anime illustration and some form of like ink painting. And if we look at the motion Lora here that it's downloaded from, we can see that the author of this Lora has really optimized it for this this ink painting aesthetic. So what that also tells us is it might not be really optimized for prompts that are outside that, you know, that domain of ink painting. So if we go back to the Lora B and turn the Loras on and have a look at the prompts, all these prompt words, I'll see if I can just find the motion Lora download. If I go up here to the Lora section, where are we? Lora here. Okay, so here's a Civet AI link. It should also tell us a little bit about the prompts that they're using. So if I just close this. Okay, where are we? and I'll click on one of these images perhaps. Okay, so here's the prompts. And you'll see they've got some stuff that's like really quite specific, keywords here that they might, I'm not quite sure, they might relate to something specifically in the data set, you know, hanfu, just describing a particular type of clothing. So you can see that these prompts are really, really specific. If I go back to ComfyUI and I change this to something that's like a lot less specific, we might not get anywhere near like the quality that we've got in terms of like image coherency here. But I don't know, if I just put in like, because I don't know what some of these specific words are, painting of bamboo, painting of rock, traditional Chinese ink painting. I don't know, I'll just put in that and see what happens. My guess is it won't be quite as good because it's not exactly what the Lora was trained on. I don't actually know what these prompts are, so if I remove these, I think it'll probably be nowhere near as good. And my guess is I'm going to remove some of these negative prompts because they're all related to people. But again, I'm pretty sure if I run this, we won't get exactly the quality that it's intended for. But I think that's what... oh, that's right. I've also got to just change this to my own file directory of where my Lora is loaded, because this will be from looking for the directory on Manho's computer. So you'll probably get that error too. So now I'm just queuing the prompt, it's running. I'll just pop over to my terminal window, and this one's running pretty quickly. I think it's going to be done in, looks like about 30 seconds. But as I said, I'm not super optimistic that the results will be like amazing because this Lora is trained specifically to make the images that are on the Civet AI site. Okay, so I think this should be done in about 5 seconds, and let's see what we get. Okay, not too bad. Okay, so it's not actually too bad at all. That's better than it's better than some of the results I got before. So hey, you know, but also I did cheat a little bit because when I looked at the Lora, I also saw that there were these types of paintings. So I was kind of pushing the prompt in that direction. But I'm surprised that that was, you know, better than I thought I was going to get. Okay, so let's keep moving through the document. So far, so good. So now let's look at the IPAdapter. IPAdapter, sorry, not reading things properly. Okay, so let's see what Manho has said about the IPAdapter. So by using an IPAdapter, images can be used as prompts to guide the image generation. We can use IPAdapters for single or IPAdapters for multiple, using one or multiple images as a prompt. Manho has given us these 2 workflows to try, and also a link to lots of others. So let's just go and grab those workflows now. So if I look for IPAdapter single, grab this JSON, drag it into my ComfyUI, and okay, let's look at what we've got. We can see the Lora has been, it's still there, it's just been turned off, so we'll leave it turned off, and I'll need to just set the checkpoint to my own, I guess, Stable Diffusion 1.5, and then we can load an image. So if I click File to Upload, we'll have, I think, in our ComfyUI folder, we should have something called, where are we? Input, and we can put all these images here. So this is where Manho had the jellyfish picture, but you can put in whatever you want. I'm going to put in, maybe I'll grab a frame from the original animation. Why not? So let me just grab that. Just give me a second. Go into the teaching folder, 3D fundamentals, frames. And my diffuse past one of these. Okay, so I'll just pop that here, press paste. Now I've got this, one of our Vanitas files. The other thing that Manho told me is that these actually do sample a square image space. So when we look at this, we're actually only probably going to be sampling the middle of this image, but let's just see what happens. So I'm just going to choose a file to upload, and I'll go back to my AI folder, ComfyUI, inputs, grab this image I just made. Okay, and let's see if this will run. Let's look at the prompts. The prompts probably need to change because we've got this and then portrait of a woman standing, masterpiece, best quality. Okay, so that seems a little bit weird. What if we do like, I don't know, what's something we can do? Objects, kitchen counter, cans, bottles, books, cooking, and what if, let's try this, masterpiece, best quality 1.2. I have no idea what that really means. Yeah, I don't know, let's give it a try. And I'm going to remove all these things to do with skin as well, because that kind of makes sense to me, because we're not talking about people. And I'll leave everything else the same. Let's just see what we get. See if it throws any errors or see if it lets us run it. So let's try. Seems to be okay. And we can see where it's running. It's now in the IPAdapter. And if I just pop over to my terminal window, we can see that we've done the first step. So we've done steps 3 of 20 now. So yeah, this will be done in about 30 seconds. And again, I'm not sure exactly how well this runs based on like the type of image you need to put in or the type of prompt. I was just making up my prompts and I probably wasn't looking at like exactly how prompts should be worded. However, let's just, I don't know, let's just see what we get. Oh yeah, I remembered I did some cool prompts with this before. So let's see what I get here. And then I had an idea of something to try. But let's just see where we get. Okay, that's funny. It's kind of taken the image and it's stacked everything up into like totally different vases and like more stacks of gold, and then the skull has become like something kind of scary and biological. But that's actually, yeah, it's not a bad image. So let's try something else. I want to try a totally different art style, like so this will have nothing to do with the image. So HR Geiger alien xenomorph. This is just an artist who I think is really great. Illustration, horror, gore. Let's just mechanical, high detail, high quality. Okay, let's just see what happens with that. Let's cue the prompt. Okay, so that's finished. And okay, I mean, that's interesting. Some of the prompts, it looks like it really went into the pattern on the ceramic, but I wasn't getting some of the like cool weird stuff I was getting before. But okay, like, so there's much more we can play around with prompting here. I won't spend too much of the video playing around with that. But you can definitely see how the image is getting cropped, so you know where it's sampling from. And then this vertical resolution here, we could change that by changing the latent size here. Okay, so let's just keep moving through the models, because I know you want to get to the Blender stuff. Okay, so that's the IPAdapter. So ControlNet, this is where we're getting to the Blender stuff, and it's really quite interesting. In the ControlNet, what we're doing is we're using images in a different way. I'll just load up the ControlNet workflow from Manho. So let's go, what's he called it? ControlNet depth only. All right, so where's that? ControlNet depth only, drag that in. Okay, so let's have a look here. So here we've still got all the IPAdapter stuff. It's kind of cool. Manho is just like adding stuff to it and then muting it. So there's the Loras, There's the IPAdapter stuff from before. But now here's the new thing, the ControlNet. Okay, so same as before, I'm just going to make sure that this knows where to look for my Stable Diffusion 1.5. And okay, there's our text prompts. And let's just check the ControlNet. Now, okay, we are looking at these things matter here, a depth map. So remember when we were in Blender, we rendered, if I just go back to the teaching folder, we rendered depth passes. So 3D fundamentals, frames, depth passes. We rendered depth maps. And so what's cool here with the ControlNet is it knows, it's looking for a depth map. So this is very different to using the IPAdapter where it's just looking for abstract image features. Here we've got like a conditional image with a very specific type of data. And so we can use that and get much more interesting results. So here I need to check that I'm using this model that's for depth. You can see I've got another one for those line renders, but we're going to be using the one for depth. And here he's got a depth image of a shark. I'm going to change that to one of our depth map images because this is sort of what we came here for. So I'll grab, there's a depth render that we've exported from Blender. And okay, what else can we do here? Okay, I want to make an image that's in the same ratio as our 16:9 image. So this image here is its resolution is 1920 by 1080, but we're not going to make something of that size because that'll be a little bit slow. But we want something of that dimension. So I'll make the width 1080. Press enter, and now what I'm going to do is go 1920 divided by 1080, which is 1.7. Actually, I want to do that the other way. Sorry. I'm going to do 1080 divided by 1920, which gives us a ratio of 0.5625. So I'm going to do 0.5625 times 1080. Oops, so there should be a decimal point there. And see what we get. And it's going to be 607. So I'm just going to put that at like, I don't know, 620 or something. I think I probably do need to have like a cubic number there. Maybe it should be like 612. Okay, so it's telling me what it needs. Okay, well hopefully this works. Okay, so now let's have a look at our prompt. So we've got the control model loaded, the image loaded, and let's take a look at the prompts here. So instead of underwater shark, let's let's now think about our what we've made in Blender. Let's start with something that's kind of on topic. So Vanitas painting, Dutch still life, vase, flowers, skull, books, gold blocks, blocks. Let's go like Renaissance painting. Hi. I don't know. Beautiful. I have no idea if these are good prompts. Beautiful lighting. And then I'm going to remove all the negative prompts that are to do with you know, faces, because that doesn't really make sense to me, but I'll leave all the other ones in. And let's see what happens if we generate from here. Let's queue prompt, and I'll jump over to my terminal and see how long it's going to take. And I'll probably pause the video here and come back when it's generated. Okay, so that's finished. Let's see what we got. It's kind of pretty cool. It's got some weird stuff in there, like, and here I'd really have to think about what's causing this. It looks like kind of a television screen. That might be it trying to do like painting or something like that. But it's kind of interesting. It's definitely like from that depth map. Now remember, it doesn't know anything about the textures that we put on. It just had this, and it's created something that, compared to the IPAdapter, it's made something that actually like matches the structure of our image, and that's really cool. So I'm just going to do one more prompt here, and I'm going to change it completely. So I'm going to do something like futuristic still life painting, metallic objects, specular, shiny, high dynamic range, octane render. I mean, these are just some like CGI terms that I've seen people use in prompting. I don't know, what else can we put in? Like, I don't know, Chrome. Let's just see what that does. Okay, so now I will prompt it again, and let's see what we get. Okay, so let's take a look. I mean, definitely some different effects. I can see that there's still a lot of stuff we need to do in prompting, and we've still got kind of like a pretty noisy image. So there's, you know, probably some more stuff we can do, but definitely like a totally different feel. And you should be able to see here that there's a lot of fun you can have. So let's just keep moving through the models so we can get to the end of this video. Okay, so we just did ControlNet, which gave us, you know, image to image. But what if we want to make video? So here's where we look at AnimateDiff. So let's grab our first AnimateDiff workflow. So let me pop back to my ComfyUI folder, workflows, and let's have a look at the AnimateDiff JSON file, drag it in there, and let's have a look at what we've got. Okay, so same as usual, I can just drag my check model here, put it on my Stable Diffusion 1.5. Yep, okay. Okay, so here's some like kind of information. This is similar to what Manho said at the beginning in terms of like a sweet spot of 16 frames and so on. Let's just have a look at our VAE. Hopefully that should, I think, yeah, I'm just going to click the one that I've got just so it's looking in the same place. Just a guess there, but that seems to have been a repeated issue. Okay, so what we're looking at here, text to video generation. I think that's all I need to load in. So let's have a look at the text here, girl, solo, cherry blossom, blah, blah, blah. So this is what this particular model has probably been optimized for. Oh, a few other things to look at. So here again, we've got the length of the animation, batch size, so 16, we're making 16 frames. And then if you look at the output here, we're making a animated GIF with a frame rate of 8 frames per second. So that means we're making a 2-second GIF. If you start making these things larger, like high definition, things are going to get really slow unless you've got some incredibly powerful computer with great graphics card. So I'd leave these things here for now, but you know, just have a play around. So we're going to queue the prompt. Hopefully everything runs, seems to be okay. And let's jump over to my terminal and let's see how long this looks like it's taking. Again, we're doing 20 steps and it's only just done 1 step, so we can see this is going to take a bit longer. It's going to take about 4 minutes. So I'll definitely pause the video here and come back when this has finished generating. Okay, so this has worked just fine, and of course it's like optimized pretty well for the prompt that it came with. You know, it's a very like coherent image. I just want to do one more try, and let's add in a prompt that's something totally different. But let's look at the structure of what's there and see if we can get anything. Who knows? Okay, so what if we put? I'm just going to change this to one cat. I don't know. Let's see what that does. And then of course you could play around with what more. I might maybe make green eyes. Let's just see what we get. Hey. Okay, so let's cue the prompt and see what we get. Okay, so that's finished generating, and actually That's pretty epic. That worked pretty well. We've got basically like the same video, but now with a cute cat with green eyes. Okay, so let's keep moving because there's a few last fun things I want to get to. Okay, and so onto the one you've been waiting for. I'm actually adding something in between AnimateDiff and animated LCM Lora. I just want to show you like combining the ControlNet and the AnimateDiff, so we can use our depth pass render from Blender to make start making animations. And I think for our purposes in animation, this is like, to me, one of the most useful, because we can make animated content using very structured images we send in from Blender and sort of reskinning them and transforming them in a really like interesting and flexible and experimental way. Okay, so I've loaded in a model that's, let's bring it up here, I'll put in the drive, that's called AnimateDiff ControlNet.json. And as per usual, I'll just check that I'm on my Stable Diffusion standard. That's fine. Should be fine. What did I have there actually? Sorry. I think that should be fine. All right. We're going to leave this here at -2. The next thing we really want to check is our ControlNet and the images that we're feeding it. So the ControlNet here, that's going to be, as we looked at before, taking semantic, like conditional structure from an image and combining it with these text prompts. So let's look into loading the images. Here I've already got it set to my depth pass, but you can just double check that. I think I had it, let's just check. Should be in my teaching folder. Go to my frames and go into my depth pass. Here's my depth frame renders. Okay. And we're going to select here, I'm just selecting every 10th image because I think it will do some interpolation in between them. We're going to do 20 steps and we're going to set a frame rate of 8. That's fine. I'll just leave all of this as I had it before. Our batch size will be 30. So that means we're going to make 30 frames with a frame rate of 8. So what's that, like a little bit less than 4 seconds or something like that if my afternoon maths is okay. And then my prompt, I put in something, yeah, kind of similar to our still life, Dutch Vanitas painting, flowers, vase, book, dominoes, skull. I don't know, why don't I add a few more, like oil painting, high quality, I don't know, something like that. I'll leave the negative prompt as it is. Okay, I think that's all good. I'll also put an image output here because I think this is a good image. What did I say? It was save image. Save image. I'll put this here because we want to get our frames. Yeah, and I'll call this like Vanitas or something like that. Oh, got to hit enter. Okay. All right, so now hopefully we should get our frames and we'll also get like an animated GIF that it will compile here, but I think for our purposes, frames are what's the most useful thing. So this, yeah, this should be exciting. Hopefully it all works. Let's just hit Q prompt and I'll pop over into my terminal. This I think might take a while, so I'll pause the video, but yeah, let's just see if we get an idea of how many steps it takes. Look, I'll pause the video and I'll see you soon. Okay, so that's worked really well. It's kind of funny. We've got some interesting stuff like the ball is turning into the skull for a brief moment, but and you know it's still a bit noisy. Our samples are probably a bit low, and I'm sure there's lots of other settings we can tweak. But here we have an animation. So some of you might be wanting to work at higher resolution or making longer sequences. These are things where you might look at, you know, what kind of computer you have, or just getting used to like a reasonably long render. This took about 8 minutes for me, but at least, you know, we've got an animation. And importantly, we've got all our frames. So that's gone out to my output folder, and there's my animation frames, which then I can, compile independently or really do whatever I want with. Okay, so now I'll move back into Manho's tutorial, and we'll take a look at the AnimateDiff LCM Lora. Okay, so we've just done the AnimateDiff. Now I want to use, let's check out the AnimateDiff LCM Lora. So that will give us text to video generation using LCM Lora with denoising steps. Now my understanding of what we're doing here with LCMs is we're sort of like doing some way to speed up the process, basically. Like under the hood, we're doing like denoising operations that should speed up like the amount of video or the quality of video we're able to produce relative to the amount of computing power that we have on our machine. So let's just pop over and grab, if I go to my workflows folder, and I'll grab the LCM Lora, Animate Diffusion, LCM, oh, maybe that's meant to be Lora. Yeah, so that's just a typo. I think that's meant to be Lora. So I'll just drop that here. That makes a bit more sense. Okay, so same thing here. Well, so if we're talking a Lora, that means we've got something that's sort of, pre-trained based on a specific, like, smaller data set. I'll just set my my backbone model to my standard Stable Diffusion 1.5. This time I'm going to use the one that's got LCM, safe tensors there. And the Lora I'll have here will be LCM Lora here. And the VAE, let's just check. Okay, just check it's reading something from my my directory, and then let's have a look at what we can put in. So we're going text to video. So in that case, we've got text here, and we're going to video. Oh, actually, okay. So with LCM backbone, that's actually what I've just set up here. I've just gone here to the Stable Diffusion 1.5.8 with the LCM backbone. So I'm just going to skip straight to this step because you can sort of go through some more of these in your own time. So I'll just grab the LCM backbone. Oh, I think I'm already LCM backbone. Okay, well look, let's just see how this runs because I'm not sure. It's getting a little late and maybe I'm either blind or missing things. But okay, let's just see how this runs because I've set the LCM backbone here. And I've set an LCM Lora here. And I liked the one cat. I thought that was fun. And I guess let's just see what the difference is. So I'll put it, let's do, I don't know, red eyes or something different. I'll move the reference to body because that's probably a bit more human. And one side, don't need that. And let's just see how it goes. I'm going to put my save output flag here to true. So it should just pop up, I think, in my output folder or something like that. One other thing, when you're using these animate diffs, you can also add, I think it's like, if I go here and put in like image, or sort of like, should be like export or something like that. Oh, no, not export, so save image. I think what we can do here, we can also connect this, and if we were doing like the format of like a PNG or something, I think we could just have a folder here like ComfyUI and just have like frames, which I think might make a lot of sense. If I go into my output folder and I made a folder called like frames, I think I should be able to do something like ComfyUI /output/frames. And I'm kind of curious, I think I might have forgotten how to do this a little bit. Our input here is image/GIF. So I'm just curious if this is going to mean we're going to get the frames output here as well. let's just see what we get when we run this. So our image is going out here to images, which is combining it into a video, but here it should batch it so that we get, what did we say? We're getting, we're going to get, hopefully we should get 16 frames here from here. All right, let's just see if this works. I'll just pop over to my terminal, see how everything's going. It's loaded the models, it's running, and I'll just pause the video to see if we're going to get to the end here. Okay, so the output here is super different. Obviously, you'd have to play around with the prompts a bit to work out what in God's name we've got. The save image function has worked. So this I probably should have mentioned a little bit earlier, but basically, like if I go here, you know, I think the way I'd set it up, I haven't quite put in the file directory correctly. So we got a new folder here, ComfyUI output, but most importantly, we've got our frames. And that means we've got like a lossless output. So instead of having like a compressed GIF, we've got frames that then we could animate in Blender and actually start to use like artists would use them and, you know, rework them in more conventional ways. So this I think is really cool. You know, it's showing that we can go from like in and out of these AI pipelines, sort of using them as we need to. Okay, so the final example in Manho's document here, LCM, which is looking at an LCM Lora to decrease the requirements of denoising steps. So in my understanding, I think we're in some sort of similar territory here, because here we've also got an LCM, but let's just open that workflow. If I go back here, workflows, and the final one is Lora LCM. Okay, so let's drop that in. And here, it's got two Loras. One of them has been muted, the other one is turned on. We've got the prompts that probably came with this trained Lora model. And then, you know, we can save the image here. If you want to unmute that, remember it's just Command B or Control B, and our preview. Okay, so I think this is getting pretty self-explanatory here. You know, we'll just, you know, select, in this case, I'm going to have the LCM Stable Diffusion 1.5. Just check I'm on a Lora that's pointed to somewhere on my machine. And yeah, I don't know, what if I... Okay, so this is still, I think it's still the Lora that's looking at this Chinese ink painting thing. I'm curious if I put in, I don't know, portrait of an elephant. Portrait of an elephant standing. Who knows what we're going to get. Okay, so let's run this and see what we get to. The last thing to look at here is that we've got this Lora sampler here at the end, which should be doing this denoising. And we've got some notes here. The terms LCM, turbo, and lightning are about modeling the speed up. So you can use 2 to 8 steps to infer the output with these models. So steps here, you remember we usually had around 20, and now we could put that down to 2 or leave it at 8. So that is where we should be getting our speed increase here. And I'm just going to leave this what it was, which is LCM. Okay, so let's just prompt that and see where we get. Are we going to get an elephant standing in willow branches? Let's find out. So I'll just pop back over to the terminal. That's already halfway done, so this should be done in about 5 seconds. And let's have a look and see what we get. Pretty weird. Okay, so again, I think we're getting back to this issue with Loras that they're, you know, pretty specifically trained. And here we've got like an elephant behind the woman. Let's have a look and see what was the prompt looking for. You know, maybe even some of this stuff like looking at the viewer. You know, who knows? But again, I think you get the point by now. Okay, so I hope that was like an interesting like bit of a trip through ComfyUI for you. And if we go back to some of our outputs in the outputs folder, there's all sorts of funny stuff that that we made along the way, these different images. And yeah, I think this will just be the starting point. I'll probably make a second version of this video once I've gotten my head around things a bit better, but I just wanted to get us started. So, okay, that's it for the end of the video. Bye-bye.